Hello everyone, my name is Kotilwar Girish Rajkumar. I am a third year ENTC student from VDF Group of Institutions, Latur, Maharashtra. Today I will show you the washing machine simulation, the project I did during the internship at Emerzi Information Technologies Private Limited. We will go through these contents by by each. First, introduction. So this project simulates an automatic washing machine using a PIC16F877A microcontroller. It performs various key functions like program selection, like selecting wash modes, controlling water level, operating the motor for wash spin. Also, it gives buzzer alerts, and also it has some safety for door closing and opening. In this simulation, we have used the embedded C programming. So why embedded C programming? Because it is a special version of C programming specifically designed for microcontrollers. It allows direct control of hardware like ports, registers, timers, etc. It's fast compared to other programming languages. Hence, it is also very efficient. It uses very less memory and is also easy to transfer from one system to other system. So, what are the types of embedded system? Like there are various types of embedded system. First, standalone embedded systems. They work independently. Means, like for example, like washing machine, microwaves, they work independently. They have a fixed program and they only do that program. They perform operations based on that program only. Then there is second type, real-time embedded systems. One of the example for real-time embedded systems would be airbag controller. It respond real-time embedded systems responds with strict times, uh, like airbag. Uh, Next one is network embedded systems. uh, they are connected over networks, means they can communicate over networks. For example, like smart meters, our smart bands, mobile phones. These are some examples. uh, Next, the last type is mobile embedded systems. Here the small portable devices come in this category comes in this category, such as portable devices such as smartphones and cameras. So, what are the different components of embedded systems? Uh, so first one is the main component of embedded system, that is microcontroller or a microprocessor. It is the main, it is the heart of embedded system. Then there are memory options, different options for memory like ROM, RAM, EEPROM, SRAM, DRAM, etc. And then the next are IO ports. IO ports means input output ports where we connect different peripherals such as sensors, actuators, switches, displays, buttons, etc. After that, timers and counters. It's also a very main component of embedded systems. Timers and control counters helps us to get precise delays, times, and next is communication ports. Communication ports helps the embedded system connect with other peripheral devices. And the communication ports are, for example, USART, I2C, SPI, UART. These are some communication ports. And last one is power supply and clock, which provides electrical supply to all the embedded system. Then, what's the difference between microprocessor and microcontroller? Microcontroller has a CPU plus RAM plus ROM and input output on the same chip. Means it is a on the same board we have CPU plus RAM plus ROM and also the input output ports. But in microprocessor, only CPU is there and we need external memory plus input output ports to connect to the microprocessor. The third difference is microcontroller is designed for control tasks and it is compact in size, but microprocessor is designed for computation tasks. In this project, we have used a PIC16 F877A microcontroller, and we will go through its features. First, PIC16 F877 is an 8-bit microcontroller which runs on 20 megahertz clock speed. Also, it has 14 kilobytes of flash memory, where we stores the program, and has a 368 bytes RAM for memory for temporary data. Uh, Also, it has 256 byte EEPROM for storing data permanently. Means here we can store 256 bytes of data permanently. Also, it has with all of this, it has 33 inputs and output pins where we can connect different peripherals such as LEDs, switches, LCDs, etc. It has PIC16 F877 microcontroller has three timers used for timing operations. Also, it has 8 analog input pins for sensors. Also, it is used to control the full washing machine cycle, and it can also generate PWM signal for motor control. It can handle interrupts, respond to urgent events, and it has a watchdog timer which resets if program is stuck or hang. So what are the different peripheral devices in this project? So the first one is LED to show the status. Example was means showing the status. After that, we have switches. Switches are used for the inputs. Example start, stop buttons, etc. And then we have pull up, pull down registers to prevent floating inputs. Interrupts. Also, we have interrupts to handle events like emergency stop. Like if someone opens the door during the washing machine during the run operation, then interrupt will stop the program from executing. Then we have timers for cycle timing for 1 minute time, for 2 minute, etc. Also, we have able to keep to select the wash programs. Then we have used the CLCD display to show the status of the program. And then buzzer, we have used a buzzer and fan or motor as to show the sound of completion and washing cycle. For that, we used a fan. And the tools we used are MPLABxIDE for the code development, where we type the tools used are MPLABxIDE, where we did our code development, and XC8 compiler. The compiler is used to convert C code into the hex code, and that hex code is used during the simulation using PICSIMLAB IDE. Here we simulated the PIC hardware using the PIC microcontroller. Now I will show you the project demo and conclusion. This is a This is a PICSIMLAB IDE. Here are some options for such as load hex, reload, save. So these options like the hex code, the C program code we return is converted into hex code. And here are other options like selecting the board and selecting the microcontroller, which is PIC16F877A, and other options for serial terminal, oscilloscope, etc. So I will load the hex file into the PICSIMLAB, which we have created in MPLABxIDE IDE by writing the embedded C code. So this is the PICSIMLAB IDE used for simulation purpose, uh, designed by Microchip. Only it is specifically designed for PIC microcontrollers. So in MPLABxIDE, we have developed the code in embedded C programming. And by using the X8 compiler, we have converted that code into hex code. And now, if I press key 5 to turn on the washing machine, it will power on like this. Now I press the key 5 like this. It will show us the washing program options screen. There are different options for washing program for washing like daily, heavy, delicates. And if I scroll through different options, here are like daily, stain wash, eco cottons, woolens, bed sheets, rinse plus dry. Here are so many options to select. And back here, with this, we can go back to our main position. And after selecting the first option, we will go to the next screen like by pressing the key. Here we can select the water level, like how much water we want, like auto, low, medium. And if we go through scroll through it, we can also see other options like if I scroll like this, high, maximum option, auto option, and back to the auto option. And by selecting the auto option, we can go to the next screen. Here, here, we can press the switch 5 to start the operation, to start the machine, or switch 6 to stop the washing machine. Now I press the switch 5 to start the washing machine like this, and it will start the washing machine. Here it shows which function is currently going on, also a timer of how many seconds are remaining or how much time is remaining, and the start and stop button, start and pause button. If I press 6 button, 6, it will stop like this, and it will stay pause until I press the start button again, and like this, it is also started. And it also stops like this. If you press any of the button, it will do accordingly. And if I restart it like switch 5, I press, uh, it started. And if I mistakenly door open, yes, there is also a interrupt handler. So if we open the door, it will show the door is open and the program will stop for some time. Uh, and if the timer goes to 0, the buzzer will also ring, showing that the machine has stopped the uh, from running the program. And like this. Now conclusion. This project demonstrates the simulation of automatic washing machine using the PIC16 F877A microcontroller programmed, and which we have programmed in embedded C. It replicates washing key washing functions like program selection, water level management, motor control, door safety, and buzzer alerts. The choice of embedded C enables low-level access to hardware components, such allowing precise controls of input-output pins. Is During this internship, during this project we have used the PIC16 F877 microcontroller along with the memory, input-output ports, timers, communication ports, etc. And peripheral devices like LEDs, switches, keypads, and CLCD displays, motors, buzzers, etc. And for the making of this project, we have used a tools such as like MPLABxIDE for coding purpose, the X8 compiler for compiling the code, and PICSIMLAB IDE for to simulate the microcontroller and peripherals virtually. In conclusion to this project, successfully demonstrate how embedded systems and microcontrollers can be used to automate and control real-world applications like washing machine. It strengthens understanding in areas such as embedded programming, hardware interfacing, and system design. Thank you.